Hello, this is Wagen, and this is the second video in a series of videos in which I will be introducing ArcGIS 10.7.1. Now in this second screencast I will be addressing three main things. The first thing is I will show how we can georeference a map without any coordinate reference system, without any coordinates, so just a flat image containing some spatial or topographical information, how we can georeference that using ArcGIS. The second thing is I will be showing how you can go to online data portals and get data from online data portals into your GIS environment, as well as a tool to do that from within ArcGIS. And the third thing is that I will be showing how you can digitize some data using ArcGIS. Okay, so to start with the georeferencing, and let me get out of this layout view where we ended in the last video, to get back into our working environment. So let's recapitulate what we have here. We have the AHN3, which is an elevation data on our research area. We have here a shapefile containing the archaeological feature interpretation. We have here a shapefile containing actually the verharding, which means the street levels and highways, etc. So everything that is built out of concrete and stone in the area, but not the buildings themselves, only the levels on which you can walk or drive. Then we have a layer in which we selected the first layer of all archaeological trenches and visualized it, and then we have here the finds. Now what we are going to do is we are going to get a raster file, which is a picture with topographical information, and we are going to georeference that using the information that we have in our map here. So using the information on the roads and streets, etc. And possibly the elevation data to georeference that and to place it on its right location in the map. Okay, so the file that we want to georeference is here in our dataset. And this is the file te georefereren met verharding, so to georeference with the information in the shapefile with the verharding, so the streets and the roads. I can double click on it. I will see then that it has three bands, and if we look at it in the through the Windows Explorer, let's take a look. We can see that this is indeed a raster file. It's a JPEG, and it contains topographical information in colors, and this is indeed what I have been talking about in the first video, a so-called multi-band raster in which we have RGB values stored in these different bands. Now I will add it to our map in this way, and then we'll get a message that was to be expected. The following data sources are added. You added our missing spatial reference information. The data can be drawn in ArcMap but not projected. Of course, because there's nothing of a projection coordinate reference system defined for this file whatsoever. So if we edit now, contrary to our archaeological trial trenches that appeared on their right locations because they had coordinates which made sense in this coordinate reference system, our map is not visible. So if we right click on the map and we zoom to layer, we can see that it has been inserted. But if we look where it is inserted, we can see that in the left upper corner, if I would be able to point as exact as possible, but look to the coordinates here in the lower right end of the screen or for the interface, you can see that the left upper corner has been inserted on coordinate 0, 0. So obviously this is not anywhere near our research area, and it is because there are not even coordinates related attached to this file. So if we would zoom to full extent, you can see that we have now here the research area with all data, which is very small, and then probably somewhere down here in the left lower corner of the screen we would have our topographical map, but we're not even seeing it because the distance is so big and the file itself, the geographical extent is so small. So the georeferencing is actually the process of placing that topographical map on the right coordinates in the coordinate reference system we are working with. So let's go to the map. Okay, so in order to georeference this raster file, we have to switch on a toolbar. So if we right click on any vacant area in the program interface, we get a list of toolbars that we can turn on and off. And if we look at the G, we can see here the toolbar georeferencing. So we click on that. And actually, I want to make these toolbars part of the interface. I think that's better that they cover the map canvas by floating over it. And now here we have our georeferencing toolbar in the interface of ArcGIS. Okay, so the important thing here is that we set the raster file that we want to georeference properly, otherwise we will be creating a mess of things. So here in this selection screen we have to make sure that the right raster is selected, which it is. Here with the georeferencing options, we have a few tools which are useful. We have auto adjust, which means that it will try to process the information that we're going to give the reference information we're going to give as directly as possible, which is useful because you can immediately see whether you have good or bad results. We can here set transformation types, which are going to be important once we have some reference points, and then we have some basic options. Now, first of all, I want to show how to use this fit to display option, because it's very useful. As I showed these two, this raster is very far because it's at this coordinate reference system source point of 0, 0. So what I want to do is I want to go to our research area, and as you can see here, we see that there is a general correspondence. Of course, we see that the information on the raster more or less covers this area. Now, if we are sure of that, we can use the fit to display to make sure the image is just, let's say, brute force transported to this area. So now we have the image at least more or less on the right location, so it will be easier to make the comparisons and actually place the feature correctly on its right location in this coordinate reference system. Okay, then about the basic process. So what are we going to do when I say we add the reference information? We are simply going to point and click using the Add Control Points tool. So the Add Control Points tool is a tool with which you say, I want this source point on my image that I want to georeference. This source point corresponds with this point in my coordinate reference system, such as I'm using it in ArcGIS. And if you feed the program, the georeferencing tool, enough reference points, it is able to reproject the information in the raster file, so it actually is properly referenced to our data. Just remember that this fit to display action that I just performed is an on-the-fly graphical projection now in ArcGIS, and hasn't changed the file in any bit. So if I would now remove it and add it again, it would still be visualized at 0.0. So we're now going to start the process of adding these control points. And in order to do that, it is important to make sure we can easily switch between these two files, so that we can either do that by turning it off and on and looking for reference points. And another way to do it is to go to the properties of this file, go to the display tab and set its transparency, for example, to 50%. So we are able to look at both the information on the topography raster as well as the information that we already have in our ArcMap. document. Let's switch off the AHN because that kind of confuses the information. I will switch off everything except from the shapefile with the verharding, so the streets and the roads. And now if you look properly, you can already see matching elements. So we have here on the topographical raster, we have here the main road with these two roundabouts, and we see that we also have them in our referenced data. And then there's some other information that is visible as well. So we can use that, for example, here, corners of buildings. So we can use these corresponding points to actually start adding control points. Okay, so let's do that. And I will start here, zoom in to start adding these points. So you can see here that we have these little buildings over here, which correspond to these two empty areas in the shapefile. And then I have this corner here, and that obviously corresponds to this corner over here. So if I want to add a control point in order to be able to georeference, I will click on the tool. I will click on the source location on our raster. And I have to say that clearly the result will be dependent on many things, and of course the result will be dependent on the information at hand and the precision and the resolution of your data in any case. And you can already see that the cells of this raster do actually quite a bad job of describing the shape of this building. So there will be a degree of error when I click on this corner, but this is not a very precise identification of this corner. So we can already say that this is going to be a general reference, and we can use the resulting georeferenced map for illustration. It may be rough comparisons, but we shouldn't try to use it for exact coordinates or measurements. In any case, having said that, let's start adding the first control point. So I will say this is my source point, and then I will select this the corner of the building in my shapefile. Okay, now because we set auto adjust, it already processed this move, so it already shifted a little bit the location of my georeference, my raster file that I'm georeferencing to its right location. But clearly, apart from the location, the scale of the information on my raster is different, because the distance between the building on my topographical raster and the edge here of this street at the roundabout is much shorter than the distance between the same 2 points in my shapefile. So there's a scale issue here as well. And these are exactly the types of things that you are correcting when doing the georeferencing process. So I can go about this by selecting another point and making sure that I connect it to its corresponding point. And I will do that by selecting this corner over here and connecting it to that corner. So I'll select another source location, click on this one, and there we are. So we can see that we are now progressing. So actually with these two control points, 1 and 2, we already have a good match between our two files. You can see that the information now here on this roundabout, where we added no control points at all, is kind of matching roughly to the information on the topographical map. So it's not too bad, and we can go on with this. Let's just add a third point to have a bit of data to work with. So you see here that, for example, we have this here. Let's switch off a bit the shapefile so we can see it a bit better. We have here these empty areas, probably containing some grass or plants next to the roundabout. I want this corner, and I want to select it, create a source point, turn on the shapefile, and then that should be that point. So I now want to connect it to that point. So I click, and then it shifts again. Now actually you see that this is actually maybe worse than it was, because the circle here that was corresponding more or less with the center of the roundabout is now more off than it was. So this is probably not a very good reference point. Now we can do this visually, controlling the arrow points, looking at the degree to which they cause a better or worse correspondence between the two files. But there's also another way to do it. So if I click on this icon over here, I can look at the link table. Okay, so what can we do with this link table? We see here 3 points. Indeed, we added 3 links. We have an X, a Y of the source. So this is referring to the coordinates of the raster image as it was inserted on the 0, 0 coordinate in the left upper corner. Then we have the destination X and Y. So these are the coordinates that we generated by clicking on our research area locations. And then we see here a number of residuals. Now these residuals are the result of a mismatch between the totality of control points. So you can imagine that if you have a control point that makes a shift upwards but not to the left or right, and then you have another control point that actually makes a smaller shift upwards but has some movement to the right of the original control point, then you have information that is going to create a tension. And of course this is only happening after adding the third control point, because then there may indeed be contradicting information being fed into the georeferencing process through adding new points. So this mismatch between these points can be actual useful information, because it may be that the raster you're going to georeference has been drawn in a totally different projection system, may even contain errors, it may be skewed for some reason, or if you scanned an analog, a paper map, then you will have distortions at the edges very likely. It can be even an intended bird's eye or view or something with a bit of perspective. So there may be many reasons why you would be, let's say, violating the Cartesian structure of your raster with topographical information. And it may be information that's useful, because you would then need a different transformation to actually get the data in a right way onto your map canvas. Now, this refers actually these different types of ways to which you can distort your original image to fit with your the coordinate reference system in your map canvas, and these are called transformations. Now, for example, we have here a couple of transformations. And we can do for example, a 0 order polynomial transformation, which basically only shifts. So if we select that, this means that the properties of the raster image are completely respected. It does not skew the topographical image. It does not make a trapezoidal distortion of it. It does not allow for scaling or rotating. The only thing it does is it shifts. So it places the image with exactly the same dimensions onto the location that it can find out through your control points. Now, what happens if we select just the shift transformation? And yeah, I think it is difficult to literally see this in our map, but we'll see some difference with the other types of transformations. But the important thing that we see happening here is that we will now have residuals. And these residuals are indeed expressing the mismatch between the points you clicked on the topographical raster and the points that you told ArcGIS that they should be in your coordinate reference system in your map canvas. So these residuals are actually saying, well, this point is actually very far off where it should be, because I have to respect the original form of the topographical raster. I cannot translate, rotate, or whatever. So this is the best I can do. And then the mismatch between in this link where you pointed on the original file and where it should be in the map canvas has a value attached to it. So it's this big. Now, in case we would know that a shift transformation would be the way to go about it, and it would be actually get us the right result as long as we would establish the correct links. Then what we would be doing is we should look at these links, see which one of them has the largest residual error, which is the least squares error, by the way, and we should try and identify where the problems are, then delete those points, and we can delete those points using this function over here, delete control point, and then we can just reestablish another one and go on with that until we have a satisfactory georeference for our data. Now, there are other types of transformations, as I said. So we can have a first order polynomial and affine. Now you may have noticed that the shape of the topographical raster changed a bit. We also now have 0 residuals, and the first order polynomial affine allows for, in addition to the shift, it allows for rotation, it allows for scaling, and it also allows for skewing the data. So with these 4, let's say, variables to manipulate, the transformation algorithm actually can get all these control points exactly in the map canvas as we want them to be, and then the residuals go down to 0. Now, other options here are similarity polynomial, which is actually between just shifting and affine. And the similarity polynomial means you can shift, you can rotate, and you can scale, but you cannot skew. So then again, the aspect ratio of all the elements in your topographical raster will be respected. And if I do that, you can see that I have residuals, but because we allow for rotation and scaling, these residuals are much smaller than with the first transformation option 0 polynomial. Now, to finish the set, there are some more options here. We have second and third degree or order polynomial transformations that just increasingly allow for more complex type of distortions. Then we have spline on the other hand, so where the polynomial options actually try to respect as much as possible the global order of your data. So they try to respect all the distortions that they allow are global in the sense that they affect the complete image. The other option, or let's say the other approach to this, would be to use spline, which is also known in other contexts as rubber sheeting, in which you actually try to get the local distortion as little as possible. So you allow for distortion at a very local level, but then the global information and is not respected anymore. So you won't have any global structure in the way to the degree to which your data is your original raster is distorted. And then the final one I will say something about is adjust. And adjust is then kind of best of both worlds. So adjust tries to combine a polynomial transformation with a spline technique in order to see if that both respects global and local precision of the georeferencing as best as possible. Well, for our approach, the similarity polynomial actually should be enough, because we have data for which we know, or at least I do, that they are both recorded in the RD new system in which we are working. So I don't suspect there would be any skew to our data. So I will leave it to similarity polynomial and try to optimize for that transformation. Okay, and then the process of doing so is to keep on adding control points, removing control points that are actually making things worse or have larger residual errors, and then we can go on and until we are satisfied with the result. Now, in order to demonstrate the principle, I will leave it at this and just accept these residual errors to be not too influential. I just want this as a general reference to see where my archaeological trial trenches may be overlapping with the current topography, because the excavation has been executed before the infrastructure, as you see it here, was built. So in that way, I can very generally compare the information on the two files. So I will leave it at this, in the sense that I will not add any more control points. And then what we basically want to do is two things. We can either update georeferencing or rectify. And before I do that, I just want to show one more thing, and that is we can actually use this menu, the link table, to save the links into a text file. So first of all, this can be useful because you could see this as some kind of meta info. So this is information about your information, and someone else might be interested in how you got from A to B. So how you manipulated your source data. So if there are any very problematic errors or something, it would be possible to see if they originated in the in this process. And second, if you are unsure about your geographic transformation, you can save the points. You can send them to someone else. You can say, well, listen, if you open this file, use them as transformation on this topographical raster, can you look at the results and tell me what you think? So it can be useful to save these points. I'm not interested at this moment, so I will leave it at this. And then the difference between these two update and the rectify options, which is basically, if I do an update georeferencing, then I will have my JPEG file as it was, but I will have an additional file describing this information. So it will, let's say, bake into that file these links that describe the scale, the rotation, and the shift that I just did. And then the next file, as long as you keep those two files together, you can always open this topographical raster and have it displayed correctly. What I will do, however, is I want to rectify. So I want to save the current warp, as they call it, to a new data set. And now the topographical raster is actually transformed into, or I should say, converted into a new raster file. So if I choose rectify, I can then set the cell size. So I can then say, well, I want a different cell size. I can say how I want no data to be displayed. This is interesting because together with the resample type, these are relevant options, because you may imagine that if you convert a raster in this way, you may have for example, a small rotation. But because the raster files are by definition rectangles, because they are created by square cells, all of the same size and same orientation. So if we rotate this, we will have a new raster that will cover the extents of the rotated file, and that will create some empty space. So if I would have a rotation anti-clockwise, I will have some empty area over here, because this will have a slightly diagonal orientation in relation to the current version. And that means that the information on the topographical raster will have to be reprojected onto that new raster. So what happens is a new raster is created, and the information from this raster is projected on top of that raster. Now, what happens then is that you need to set a resample type, because there will be no perfect match between the cells of both rasters. And then there is a clear distinction between discrete data and continuous data. And with the nearest neighbor, sharp edges will be respected as much as possible. Whereas with the bilinear interpolation and cubic convolution, what more matters is an average of the cells on a local level. So the edges are not respected, but the overall values are more respected. And then, of course, we will then have no data zones in these areas for which we have no data, so you can set that as well. And then we have, of course, a name and a compression type. Now I will select the location where I want my adjusted file. So this is going to be this workspace. Yes, and I will give it a name. So I will say georeferenced topography, and I'm fine with the TIFF file extension. So, and then I will hit save. And then nothing happened, of course, because my file, the JPEG, is still in this document. But if I go to the catalog and I hit F5, refresh, I think it's, oh yeah, there it is. I will have now my georeferenced topography.tiff. And if I insert this into the map, I will have it exactly where it should be. So I could now remove this file. And just to demonstrate the principle, if I would now add the original topographical raster again, it will be again at this the origin of my coordinate reference system. But as you saw me just doing, if you add the new rectified topographical raster, it is at the location where it should be. Okay, so now as the second part of the screencast, I want to demonstrate how we can make use of online available information, either directly through the ArcGIS program or by going to data portals and downloading it yourself. And to start with, I will show what we can do from the inside of ArcGIS. And in order to do that, we can go to File, Add Data, and here we have two functions, namely add base map or add data from ArcGIS Online. Okay, so the difference between these two is that base maps are provided directly by Esri as an online service, and the ArcGIS Online is a specific environment in which you can also collaborate on data and share data, and has a huge resource of maps that you can also access. So it's just a different platform. So if we add base map data, we see that we have here a couple of, well, indeed basic maps with, for example, topography, imagery, ocean bathymetry, OpenStreetMap or terrain. And just to demonstrate the principle, we'll open the imagery base map. Now this will take some time because it downloads directly from the internet a huge file, and now we downloaded it, and we can see that we have this this file that will dynamically real-time download the necessary data from the internet to be able to display the information relating to your current extent. and that gets progressively heavy, of course. So already we are waiting quite a bit to have the imagery rendered onto our map canvas. And and maybe this is evident, but just to point out, this added an element, a new layer to our table of contents, in which we can also turn off and on some items like higher and lower resolution images. So this is a way to get very quickly base map data into our map. I will go back to our research area. And then I will show, how we can use ArcGIS data from the ArcGIS Online environment. Now, if we click on that, what we are getting into is we have here an online search tool, and a very useful source for looking for useful data, at least in the context of the Netherlands, is looking for PDOK files. PDOK stands for Publieke Dienstverlening op de Kaart, so public services on maps. And this is actually a collection of government bodies that offer their spatial information that they collect on the population, the landscape and infrastructure in the Netherlands, and they share it through the PDOK infrastructure for use. You can download them online, but you can also directly access them through ArcGIS Online. So I will now hit enter PDOK, hit search, and then we'll see that we will get a considerable number of map layers that we can download. And as you can see, this is really considerable. There are 422 maps that we can access. So we have the AHN data, we have the Central Bureau of Statistics information, we have buildings, we have wind speeds at 100 meters high. Well, it is quite extensive what you can, there are here the spread of different types of birds, and so on and so forth. So yeah, this is all being offered through PDOK, and let's, as an example, add the AHN data from this area onto our map. Let's take a look where it is. Did I just miss it? Oh, here it is. So here we have PDOK, Actueel Hoogtebestand Nederland, so this is AHN. It's basically LiDAR data, and this is the third edition of that, which says something about the resolution of the measurements. And if I then click on add, it will start adding this data to our map as a layer as well. Okay, so we have now here the AHN information, and there we have it. So this is the AHN information as it is downloaded directly from the server. Now, as you can see, we are not allowed to do much with this data, so we can use this as a reference and for visualization purposes, but it is not the same thing as downloading the actual raster file such as we have it in the AHN file that we already have been working with, but it is useful for this general visualization purposes. Okay, so it goes without saying that you can use this data from ArcGIS Online also to discover the existence of data related to your own specific research area. I showed how to get data for the context of the Netherlands, but of course there is a multitude of data files to get for your specific research area. I just typed in Greece, and I get 604 different options. So yeah, you can use this to your advantage on any area of the world you are working in. Now, what I want to show next is how you can go to online data portals, where you can get these files individually. So let's say I do not want to access them through ArcGIS. I just want to freely browse the web and see if I can find any files or services that I want to, let's say, manually get into my GIS. Now, in order to do this, I will go to open a browser. Now, let's say I'm still interested in getting this AHN data from an online source. So let's go for AHN download. Then I will have here the PDOK.nl online website, which is the actual website. Let's go to the new one. Website where you can get this data as well and find descriptions of these data. And surely many governments from many countries have similar platforms where you can get freely available data. And if I want, I can now go and search for data sets. Now I can look for them, but conveniently enough, the data set we're looking for is in the first options here on the side. So I have here Actueel Hoogtebestand Nederland, so it's AHN3, the one we were already working with. Let's look at the details. Here you see a snapshot of the total data that has been collected. And then here down this page we can see two ways of accessing the data. And one way to go about it is to get a geoservice, which is kind of similar to what you saw me doing when I accessed the ArcGIS online data. So let's say the technical data transfer methods is similar. The source is of course different. And here we can just directly download the data. So just as a demonstration, I will now get the AHN3 web mapping service. And if I want to use this, what is important is this URL. And I can use this URL to access this data directly in ArcGIS. So let's copy the URL and get back to ArcGIS. Okay, in ArcGIS we can open the catalog, and the catalog not only allows us to browse the data on our hard disks, but also allows making connections with these online services. So if I would, for example, now look for a GIS servers, I can here add different types of data sources. So there are some ArcGIS specific servers that we could set up and then get data from. But what I want to do now is to add the web mapping service server. So if I double click on this, I can add a URL. So let's paste the URL we just copied. I want the default version. I want to get the layers, and here we see actually the similar layers as we were able to retrieve through the PDOK entries into the ArcGIS online environment, and I don't think we need an account, so let's hit OK. Okay, so and there it appeared. So now we have here in ArcGIS service the specific server, and now we can just add these data sources to our map. So if we would again go for the AHN3 5-meter digital terrain model, we can drag and drop it into our map, and now we have it. So in case this is data that we already found through the ArcGIS online environment, but if you would have a web portal that only allows you to access these web mapping service URLs, you now know how you can get them into your GIS. Okay, so again, as I said earlier, this has limited functionality. So if we want to have the full functionality of working with raster data, we actually want to download the files. So let's go and do that. So let's get back. I will go back and we'll go to the download page for the AHN3. Yeah, so we click on the download sign. What's now important is that we select the right sheet. So downloading all this data can take a long time because every single sheet is about 500 megabyte. So you can imagine, if you see that all these little squares are their own sheets, it is going to take quite some time to download everything. So it is indeed wise to try and select the data sheet if you know what the one is that you need. Now I know that this is the one that we are actually looking for, so we need this sheet that I now selected over here, and the research area is over here. And then we see here, this is in the sheet 40 CN2, and we can download different products now for this area. So in order to work with it, I would really like to have the best possible data. So I want the 50 centimeter resolution raster, and I want the digital terrain model instead of the digital surface model. And the digital terrain model is the surface model, but then filtered so we do not have any buildings or trees or other types of stuff that is not representing the actual surface of the earth. Okay, so let's hit download. Yes, that's fine. Okay, and this can take some time. We are looking to 296 MB, so it's going to take a couple of seconds to download, and we'll be given a warning when it's here. Okay, so and there we have it. So what we downloaded now is a .tiff file. That is when it's not compressed, it's 500 MB and a little bit. Let's copy this into our data set that we are working with. Paste. And then it will turn up through our ARC catalog in our data set, so we can add it to our map. So just do not forget to hit F5 every now and then to see if it already is already available. And there it is. So here we have the downloaded data sheet. We can drag it into our map. Well, I addressed the issue of pyramids in the first video, and I want to create these pyramids, so let's go for it. We can see here the progress bar, so it takes some time, but here we are. And there we have our data georeferenced and everything. And yes, so now we have the data to our available to us, and now we have also full control over everything that we might want to do with it. So there you have it. Okay, and so with this demonstration of how to get external data into ArcGIS, I want to head on to the final part of this screencast, in which I will be showing how to create a new shapefile, how to open up the shapefile for digitization, and how to enter new data into that shapefile. Okay, so and what I want to be looking at is I want to see to what degree the information of my georeferenced raster has some information that may be overlapping with our archaeological excavation information. So I want to actually digitize the information on the georeferenced topography. Now, the navigation now takes a lot of time because this base map is still here. So in order to avoid delays, I will just remove this. So we are only working with local files again. Okay, so this information, I want to see to what degree, for example, the water-filled ditch that we excavated in these trial trenches and that we may see a reflection of in the digital elevation model is actually overlapping with, for example, this street. And yeah, so I will digitize this street amongst some other things as an example. Okay, so in order to create a new shapefile, I will go to the catalog. I can right click on our connected folder, and then I can select new from the context menu, and then I can see a whole range of different items that I can now make, but I want to have a new shapefile, so I select shapefile. I'll give it an appropriate name, and then I can select the feature type. Now we have point, polyline and polygon, you know this by now. We have also multi-point and multi-patch. This is a bit outside of the scope of this introduction. And it is important to know that you cannot have more than one of these geometry types in a single shapefile. So I will select polygon because I want to digitize polygons. And another thing which is very familiar by now is we have to set the coordinate system. So let's look for the right coordinate system. And we know what to look for. This is the EPSG index number of the RD new system that we need. So we select that and hit OK. And this is it. So we are happy with what it is now, and we just hit OK. Right, so now we see that to our data set on our hard disk, and we can verify this, of course, by looking at the data set. And we see here that indeed a digitized shapefile has been created. And now we can also drag and drop this onto our, oh, it's already added, by the way. We already have this automatically added in our table of contents. So we can now directly start working with this. Okay, now in order to get on with the digitization of polygons into this shapefile, just showing that we have an attribute table, of course, which has been created, but this attribute table is empty and has only the default fields because, of course, we haven't defined any further columns in which you would like to store data yet. So this is an empty shapefile, and in order to start working with it, we have to start an editing session. Now, first of all, let's switch on the editor toolbar like this. I will edit, and I will place it here in between the basic toolbar and the georeferencer because I want to have this a bit central. And using this toolbar, I can start an editing session. Now, the editing session opens up here a panel that says create feature, and we can here indicate that we want to digitize into our shapefile digitize, and what we want to construct are polygons. And you can see here that there are a few different types of shapes that you can create, which have some basic shapes that will be drawn, but we just want to have a total free approach to placing points and creating a polygon through digitizing these different points. So we select that, and then we are actually ready to go. Now, why do you need to enter an editing session? The editing session is actually locking this file, so nobody else can now open it and start editing. Let's say that this file will be on a central disk somewhere, and someone else has access to it. It is now unavailable for somebody else to digitize information, so it's a very basic mechanism to avoid the corrupting of information in these files. Okay, then let's start with the digitization process. So let's say I want to digitize these little houses over here. As said, the quality of this topographical raster is not very high, so this will only be an approximation, but for the proving or demonstrating the functionality, this is fine. And having started this editing session, my cursor changed, and it is now automatically set to create new features function. So if I would now start clicking on my map, I would in fact be digitizing vertices, which will then be tied together through polylines, forming eventually polygons. So let's go about this house over here and draw it. So I've now just been clicking with my left mouse button to digitize these points. If I open the context menu with the right mouse button, we can see that there are many options here. You can set a direction, you can set a deflection, length, change the length. You can insert absolute or delta XY values. You can enter direction and length, set it to parallel, perpendicular. Well, there are many options when you are digitizing to control the location your next vertex is going to be placed. And I won't go through all of it. Just know that you can be very precise when it comes to angles and lengths, etc., etc. Let's say I'm happy with the house such as this right now. I can just go and I could hit the function 2 button, or I can just click on finish sketch. And there it is. Now we have a digitized polygon. Yes, the digitized polygon is now also visible as a record in our attribute table. Actually, there's not much in this attribute table, and we may want to enter, for example, an ID of our own, or maybe a description, or what have you. Now, in order to do that, I probably want to do that in a new field, but the adding new field option is only available outside of an editing session. So if I want to do that, I have to stop the editing session. You can do that by hitting the editor and then stop editing. I want to save my edits. I can then go into the attribute table. I can now select add field. I will make a text field, so not short integer but text. And I will say I want a length of 50 characters, which is a bit much, but okay. So I'm able to enter what I just digitized. So now I created a field in the attribute table. And if I would now turn back to the digitization session, I can now also enter information here. So let's just say this is house number 1. And I just save the edits. Okay, now I can do in this editing session, I can using the editor toolbar, I can do more things. Let's say I want to replace this for some reason. I can very simply drag and drop it. There are other things we could do. We could, for example, edit the vertices. So I could just select the vertex and drag it, and then the shape of the polygon obviously gets changed. If I right click on an edge, so the polyline connecting these two vertices is also called an edge, I can insert a vertex, and then I can make a more complex shape if that would have been necessary, and so on and so forth. And if I would just click then outside of the polygon, my changes will have been, the polygon will have been adjusted. Now there are other tools that can come in handy. So the reshape tool, let's say I missed a corner here and I want to cut a corner out of my polygon. I start my editing outside, so I set 1 point outside, and then I will select that this is the corner that I needed to have cut out of my model. So then I just draw it, do finish sketch, and then my model is changed. My polygon is changed accordingly, and we can do that the other way around as well. If we start inside and we end inside, then we can actually add a part to our polygon, as you can see here. Well, maybe two final tools which can be useful is the cut polygon tool. So if I just want to split it in two, I can do it like this. So now I suddenly have 2 polygons that I can now manipulate separately. And if you look in the attribute table, you can see that I have indeed now 2 polygons called house 1. And a final thing that may be useful to show is how you can rotate. So the toolbar also allows you to rotate your individual polygons. So this is all functionality that may come in very handy when you are digitizing polygons. And I will now produce a series of Ctrl Z's, which are undos, to get back to where we were at the beginning of this digitization session because I just want my house back on its original location. Okay, now just for the purpose of repeating the process and showing the principle just once again, because I was talking about digitizing the roads over here. Let's just go on and make a new polygon and show that we can now just go on digitizing progressively and add all these new features to our Polygon shapefile, finish sketch, and now we have another digitized shapefile, and this we could call road or what have you. Yeah, so these are the basic principles of digitization. There's one more thing I need to mention. While digitizing, you've seen me, or well, not me, but you have seen this effect. So when I digitize and I come close, and this was already visible when I was doing the georeferencing, if I come close to a specific vertex on the map, you see this little square appearing, and what it does, and now we see the square actually pointing to an edge, and what this is this is the graphical effect of the snapping option. So snapping basically means that the area I'm going to select is magnetically, so to say, drawn to a point which is already in my map canvas. And this is very useful because if I would want to digitize something that exactly follows the border of this polygon, which can be of course very useful because usually these borders are discrete distinctions between either one thing or the other, and so it makes only sense that these borders are exactly the same. So you can, but also with georeferencing, it makes sense if you have exact points to georeference to that you also indeed select them correctly. And if you would just try to do that visually, because GIS has this almost limitless scale, it's almost impossible to exactly select a point with the exact same coordinates with so many numbers in decimals. So the snapping function is very useful, and so this allows you to very precisely digitize. Now, the snapping options are important to understand how you can set them. So if I would have a snapping toolbar, we have here the possibility to select which kind of snapping do we want. So this is just a matter of hovering over the option and reading. So you have point snapping, so it just snaps to individual points. You have end snapping, you have vertex snapping, so this is what happens here is vertex snapping. And then you have edge snapping, so now it also snaps to the exact edge of this polygon. And if we select the options, the little menu here, we can turn snapping on and off, and we can also do some more advanced snapping, things like the intersection between two polylines. Well, the most important actually is the options here, in which we can set the tolerance. And now you can imagine that if you have a very big tolerance, so I would set this to 100 pixels, and this is screen pixels, then this point is going to, well, in this case, let's say it like this: it becomes very difficult to set a point right next to the layer, the polygon, even if I wanted to, because we set the tolerance to be so big that everything within 100 pixels surrounding this a potential object to snap to is selected. So this can be useful, but it can also be very annoying. So let's say setting the tolerance to a workable level is very important. So it actually helps you and does not just is not just an hindrance, and you want to turn it off. So that's basically the snapping, and yeah, it's very useful help when digitizing. Okay, so with the demonstration of the snapping tools, I've come to the end of this second screencast in which I'm introducing ArcGIS 10.7.1. We've been going through the process of georeferencing. We've accessed external data through the interface for ArcGIS, but also by going online, getting data from map portals, and then adding it to our GIS document. And finally, I've shown how we can go about editing, and I've showed you various tools when it comes to editing. So with this, I want to finish this screencast. Thanks for listening and watching.